today, if you notice, this is an excerpt of your book, so we're just going to read through it and talk a little bit about what it means. You have learned that the measure of a minor arc is equal to the measure of its central angle. On a clock, the measure of the arc from 12 to 4 is equal to the measure of the angle formed by the hour and minute hands. A circular clock is divided into 12 equal arcs. So the measure of each hour is 360 degrees divided by 12, or 30 degrees. So each hour is 30. The measure of the arc from 12 to 4 is 4 times 30, or 120. So each of these is 30 degrees. So 30, 30, 30, 30. Okay, all the way around. Notice that because the minute hand is longer, the tip of the minute hand must travel farther than the tip of the hour hand, even though they both move 120 degrees from 12 to 4. So the arc length is different, even though the arc measure is the same. So when we're talking about arc length, okay, they're saying that this one right here would just have to travel that far, okay? The other one on the inside is going to have to travel a shorter amount. So you can see obviously that the longer one's going to have a longer amount to travel because the radius is longer than the other one. So let's go ahead and look at some of our problems today. First one, what fraction of each circle is each arc? So AB is what fraction of circle T?
1/4.
1/4, because it's like a fourth of a pizza. Okay? CED is what fraction of circle O?
Half.
Half, because it's a semicircle. And then the next one, EF, is what fraction of circle P? 1/3. Now how you could get that is you could take 120 divided by 360, which reduces down to 1/3. So consequently we have a conjecture here. The conjecture states as follows. The length of an arc equals the measure of the arc divided by 360 degrees times the circumference. Okay, so the length of an arc equals the measure of an arc divided by 360 times the circumference. Let's make sure you get that down. The measure of the arc divided by 360 degrees times the circumference. Okay, so now let's go ahead and look at the next question. If the radius of the circle is 24 centimeters and the measure of angle BTA is 60 degrees, what is the length of AB? So length, first of all, let's find the measure of BA. What is the measure of BA, folks?
120.
120, because BTA is what type of an angle? Inscribed, good, because it's on the inside. So then now also, what I end up having here is I end up having a central angle that is 120 degrees, and I know that my radius is 24. So to find the length of BA, what I'm going to have to do is find the circumference of the circle, and then take it times 120 divided by 360. So the circumference is pi times the diameter. What's the diameter if the radius is 24? 48. Okay, so far so good. So really the circumference is 48 pi. Now if I wanted the length of AB, arc AB, what I'm going to do, arc AB will equal 120, which is the angle, divided by 360, times the circumference, which is 48 pi. And that's it. So now let's reduce. 120 and 360 is 1/3. So I end up having 1/3 of 48 pi. Okay, 3 goes into 48 how many times? 3 goes into 40, 16. So your answer for the length of arc AB would be 16 pi centimeters. Or you could answer it as a decimal. Okay, to the nearest hundredth, what's the nearest hundredth going to be? 24?
No, 50.27.
Did you take 16 times the pi button?
Yeah.
Okay.
It's 50.265.
Okay, 50.27 centimeters. Okay, questions? Fairly straightforward. Let's see what we got next one. If the length of ROT, so when they say ROT, we're referring to this whole thing right here. Okay, that is 116 pi meters. What is the radius of the circle? So what we're trying to find is the radius. So if I think about this, if this arc here is 120 degrees, what must this angle be here?
16.
This angle here?
Oh.
Oh.
You would 240.
240. So now, my circumference formula was circumference equals pi times the diameter times the fraction of the circle. Right? So let's fill in what we know. What do we know that the circumference is? Huh? 116 pi equals pi times d times the fraction, which is 240, divided by 360. Okay, 240 divided by 360 we know is what? What is 240 divided by 360? 2/3. So I've got 2/3 pi times d. What do you know about your pi's? They cancel. So really I have 2/3 times d. So I'm going to multiply that by 3 halves on both sides. What is 116 times 3 halves?
174.
174. And that's going to equal my diameter. But I don't want the diameter. What do I want?
The radius.
The radius. So what are you going to do?
Divide by 2.
Divide by 2, so the radius is
87.
87, and my label will be meters. Questions?
Can you do it differently?
What were you going to do?
If 116 would be 2/3, half of that would be the other third, so you have your total circumference, and then you can just do it that way.
If you didn't catch that, McKenna was saying you have 116 pi, which is 2/3. So if you take half of this, you end up getting, what is that, 58 pi. So your total circumference of your entire circle will be 174 pi. What you can do then is equal pi times your diameter. When you get that, you end up getting, dividing by pi, your diameter is 74. Half of 74 is your radius, which is 87. So that's another way you can do it. Okay? Questions? Alrighty, so here you, oh, skipped it. There you go. There's your assignment, page 351, 1 through 8. Due tomorrow, start of class.
Okay, I have